How is Descartes' mechanics different from Newtonian mechanics? Why do you say that Descartes' mechanics unifies classical and quantum physics?
Descartes uses vortex spin and the ether to explain the motion of bodies, whereas Newton uses force and matter. For example, a 1 kilogram green ball that moves at 1 meter per second is said to have been moved by 2 newtons of force. However, this is misleading because it hides the cause of that force. In reality, that green ball was moved by another body, here shown as a bigger blue ball. The force was created by the impact of the blue with the green. Before that impact, the blue ball had no force, it only had the action of moving in space. If you take away the space, then that action reverts into effort. It is this effort that represents the spin or vortex of the ether idea represented by that physical body.
Could you explain the movement of the green ball in the Cartesian way?
Sure. To Descartes, time is made up of independent moments. So we cut up the scenario into 3 parts, with 1 part for each second, as second 0, second 1, and second 2. This gives us a universe with 6 balls divided into 3 independent moments. Second 0 shows the effort and action. Second 1 shows the impact. Second 2 shows the force. We then notate this in a Francis Bacon table to show the change from effort to action to impact to force through time. This shows that the speed of the blue ball was cut to half after hitting the green ball. This means that the blue ball had 2 units of action that was converted into 2 newtons of force after impact with the green ball, and that its action was reduced to 1 because it transferred 1 action to the green ball.
How does that relate to the principle of least action in the refraction and reflection of light?
Action comes from effort, which is based on the law of conservation of idea. This law says that every identity wants to keep its uniqueness. Each identity comes into the universe with a unique spin that makes the whole identity unique. This makes every identity relational to each other. When an identity is deployed in space, the relative differences in identities kick in. This converts effort into relational action. This action will either be transferred or non-transferred depending on the relation of the bodies. For example, 2 balls are both material and so they will transfer their actions when they hit. But a light is different from glass. So the light will not transfer its action to glass. Instead, the glass will modify the action of light to make it bend. An opaque surface will modify the action by making it bounce. This gives an appearance that nature is lazy, when in fact it is just keeping its effort, action, or spin in accordance with the law of conservation of idea.
How will the same Cartesian action principles apply to quantum mechanics?
Cartesian action shows up in quantum mechanics as Feynman diagrams. These visualize the changes in movement or nature of a particle upon impact. For example, this diagram shows the action of an electron and a positron producing 2 photons upon impact. We notate this in our Francis Bacon table in 3 parts with 12 identities in total. Instead of slowing the original particles down, the impact converts them back to the ether, while deploying 2 photons into reality, which was previously just an ethereal probability, while conserving having 2 ideas in physicality and 2 ideas in the ether. The main advantage of the Cartesian system is that you can manipulate movement of bodies by drastically changing the effort or spin of their particles. This allows anti-gravity and teleportation since space and time are made up of independent moments. Anti-gravity is used by levitating Buddhist monks, while teleportation is used by UFOs that jump from one space to another by using the ether.